Okay, so good morning. We will start today. Um, we're moving into module 3, which is where we focus on code smells and refactoring. And let me go ahead and share my screen here so we can, where are we? Boom. So, but of course I labeled the slide module 4. That's okay. You didn't notice that. Um, I kind of I I want to introduce code smells because I went through most of my career not knowing what a code smell was. I would come upon some code and I just assumed that whoever wrote it knew more than I did, and and I would just work with it. And sometimes it was easy to work with, sometimes it was harder. And I always thought it was me that, I'm just not smart enough to figure out how this code works. And it wasn't until, I don't know, 10 years ago that I found out about the concept of code smells. And I thought, well, this is why this code is hard to work on. I remember I had a, a very short contract that I worked on one time where they had asked me to, help them out with a project. And it was a fairly extensive project, and there were no packages. Everything is a Java project, but everything was in the root package. And it
Whoa.
was a Java Swing project. And it was almost unmaintainable. So
I can
I
imagine.
I went and started to create packages, and it was getting to be really hard to compile. Of course, there were no tests or anything. And I spent 2 weeks going through and trying to move this stuff into packages. And I said, I'm still weeks away from this getting there. And I remember telling him, y'all didn't pay me to go and reorganize your project structure. You paid me to get this function added, so I'm just going to add this function. And then it ended up taking another couple of months to add the stupid function because it
Yes.
was so freaking hard. And if I had
Wow.
just gone through and cleaned up the code, with the information I know now, if you go and refactor it, it would have been so easy, and it would have, you know, it would have worked. But
Imagine. Okay.
but that's why I want to make sure that we cover code smells so we can understand, this is bad code. This is code
Yeah.
that needs to be changed. And
The fir-
and
the
it's
first
okay.
company that I worked that had the legacy code that I worked with, I passed just like this because I was thinking, oh, I'm not good at Java. I'm a failure. Then I changed the comp to another company in a junior position. I was really afraid of it. I mean, I was gonna be fired because I'm a failure. No, the code was so bad that I couldn't do a task. The smallest task was a challenge
Right,
like this. I know exactly what you mean.
right. Yeah. Well, I mean, also, if you think about it, until you can recognize that code is poorly written, you can't find ways to fix it,
Yes,
right? You can't
yes.
you can't improve it unless you realize, oh, there's a better way to do this. So, and that's what I just said. So, so there's the code smells that we're going to discuss are mainly from um, this your book. Oh, should have put a picture of it in the slides. Martin Fowler's refactoring book.
Oh,
And
okay,
if
okay.
you look inside the front cover, it's got all the refactorings, but if you look inside the back cover, he's got all the code smells and
Awesome.
which refactorings would do well to handle that. So, and so basically, these are put into different categories. I forget. I should have put that in here. There's somebody online went through and said, these are good if we categorize them. You can you can think about them more easily that way. So our first category we're going to look into is called a bloater, and it's just something that makes the code too big, right? Um, you've got your long method, which we pretty much understand what that is. Your large class or your God class. This is probably the things we see the most, right?
Yes, every time.
Primitive obsession. If you're working in an object-oriented language, then generally you don't want to use string everywhere. You probably ought to create an object that tells you how long that string ought to be, what the contents of that string ought to look like. So that would be more useful. You probably don't want to use int. You probably want to use something that has, this is the range of what the value needs to be, and and give it a useful number. The advantage of that is you can, if you're creating an object that has uh, effectively a contract with how it's supposed to be used, then it's easier to make sure that you're not misusing something.
Exactly, exactly.
Your long parameter list. Um, you know, while I'm describing this, let me. There's a project I found that has. I just use it as my favorite project for finding really ugly code.
Favorite bad project.
Yeah, it used to be uh, supported. Used to be you know was it's an Android application for reading Reddit. Uh,
Wow. It's a real project, but it's really
yeah,
badly
it's
written.
it's not supported anymore because I mean
Oh,
it
okay.
took years to get updates, and when you see the
They
code,
gave up.
you'll see why. This is kind of the code that we work on every day here, right?
Wow. Oh, wow.
So this is the main activity class. It's
4,000. See,
only
5 times.
5,334 lines long,
Whoa.
and it has a rather long method here. Let's see here. Is this it? Yeah.
They served a propo they served the mission because be an example. Even if you're a bad example, now you remember this project. Wow.
Just go.
And
What
how
is this here?
lots.
Is the set drawer edge. So if I go and see that goes from 1442. Oh no, not that one. I guess it's this one here. Do drawer, 1464 to 2209.
600 lines should be a class.
That's probably a little long. Um,
Wow.
yeah. And if we go to, where is it here? So if you look here, this request code, you know,
True.
that's a value. If you look at that, um, you can see this request code is I was fiddling with this how to refactor it, so I changed the name of things. But if you look at this, we've got all these different request codes that are being used. Why don't we just make this an enum, right? So that,
That returns a value,
I
exactly.
mean, it's okay that it's good that it's not a magic number, but why not have an enum for here's what a valid request code should be
And
instead of just int.
request codes have a range really well defined. You shouldn't
Right,
receive random numbers. So
right. So, and let's see here. We go to, oh, come on. There we go. If you look at this, you want a long parameter list. Let's go way down in here. You can see this one has 1, 2, 3, 4, 5 parameters. You really want to keep this to about 3 parameters. If you're getting longer than that, then you
You
probably have to
receive an
stick all of this
object.
into objects. Of course, you got
Yes.
these are these are all objects, but
Yes.
it just gets to be unruly if you've got this many parameters. You got to go and wrap your parameter list. You know,
Yes.
you probably have too many parameters.
Define one object, use a builder to be very, very semantic about what you are doing with each parameter.
Right.
Awesome.
And then let's see, we have
Wow.
our data clumps, groups of related data values that you could probably stick in a class. And so if you look here, and you've got this. I don't know what I was going to show here, but I saw this as an example of it.
Then comes these two strings or variables assigned under in the line in 632. What are those twos declaring?
Yeah, well, so this is actually not necessarily a bad thing. You want to declare your variables close to where they're being used, which
Oh, it's
is
used under
which is not,
the
I mean,
next.
they're clearly not being used above here. So yeah,
Yes.
632. So it's used down here on line 2034. Um, but
So
yeah, well, of course, it's also being used in line 607, which is
okay,
above
okay.
630. So yeah, maybe it shouldn't be here, but it also probably ought to be, in another class. And this
Yeah, because it's
big
a huge
long
method. You
method should
have
be broken up.
yes, you have a huge method. Then comes two variables. I mean, where did you come from? Looks like someone copy and pasted in the wrong place or moved.
Yeah.
That's interesting. That's interesting. Good
So you
project.
can
Good
see why this
example.
was a hard, hard thing to maintain,
Great example.
but
Awesome.
it stopped being maintained,
They gave up.
right? So then we go to our object orientation abusers, which basically if you're doing object-oriented programming, these sorts of things make code hard to use. I tried to find examples of each, and I didn't always find it. So alternative classes with different names. That's where you have, you know, two different classes that do effectively the same thing. Different interfaces. So yeah, so we go to time utils. Basically, you've got this. They're not really classes, but they're methods. So you see
Get
that
time
you got this method,
since
time since and time ago, and the only difference here is this has got second typed out, and this minutes typed out, and this has got just M. Just so it's kind of silly. That does almost the exact same thing.
oh
Um, a refused request bequest. That's where you have inherited from a class, but you don't really use the methods that
yes.
you have inherited from. Well, why inherit from it? Maybe you
Yes.
can make it a an is a relationship instead of make it a has a relationship instead of a is a. But that's generally a better thing anyway. Switch statements. So you have large switch statements. I've got that. This is amazing here. So this is a large switch
The
statement.
biggest switch statement that I've ever seen. How
Yeah.
many
Well, I've seen bigger. I've written big. If you're doing like, I don't know if you ever did a sax parser for parsing XML.
Mm, mm.
Um, if you have a relatively complex file, these things can go on and on and on. So we
Wow.
do lots of XML in the project that I work on.
Okay.
But you also have things like this, where you've got
Yes.
this if else if, and then it goes and indents forever.
The Christmas tree.
Yeah. So you in a lot of these cases you can break this out into a method. Um, break this out into a method. Hey CD, really?
Esqueci de.
CD. So I guess these are if it's a special project or something. Anyway, um, we also are looking at uh, temporary fields. Um, yeah, you've got a class variable, so that would be, let's get to the top. These are your member variables here, class variables that are available to the whole class, but they're only used in one or two places. So
Could be a method variable. Oh,
yeah, maybe, but or you need to break that up into
a
smaller
smaller class.
classes so that
Yes.
the class variables are used only in the class. So yeah, but yeah, we can see that these
Very clear.
are smelly things. Um,
This this switch statement, we have some code there that abuses of the visitors pattern because they have to do a lot of if, see if it's
right,
a method, and they do almost the same processing but differs in some details. So they implemented I don't know if a class or if it's an interface. Then come visitors for each class, but the
right.
code is full of visitors. It's a nightmare because every time you got to go, oh, accept, and then you see what's accept, and then
Okay.
go to the and there's this smaller class. It's the other side. They tried to leave the if else switch and end up with the visitors patterns everywhere. It's a nightmare.
Yeah, yes, yeah. Sometimes like where do we have it here? The
Uh,
like this case statement, this sort of thing. You don't necessarily want to create like a lot of times you replace this with a strategy, and but you don't want to have a strategy for each one of these. Um, or something like this, you don't want to have a whole nother class. But so this may not be the wrong way to do it, but if you're seeing something like this, it probably suggests maybe you could turn that into like what do you call it, a collection of values and lambdas or something, just to keep it a little easier to read, break things up a little better.
and even using the case switch, you extract the methods to methods itself, not
Right,
going inside and open keys and starting, yes, inserting
right.
code in the middle of the case switch.
These things should be broken out into separate methods. Yeah.
Exactly.
Okay.
Very clear, very clear.
So our next group would be our change preventers. If you make a change in one place, it's going to require a pile of changes elsewhere. Um, you know, basically, this whole project obviously is a change preventer, which is why they couldn't change it anymore, why it's not supported anymore. Um, go back. Um, yeah, you change one place in a class, you're going to have to change it many other places. So if you decide a variable needs to be renamed, or you need to uh, have I don't know, rename a class, or just break out a section of code, or you want to make a change to something, you're going to have to make a change in 15 other different places. Yeah, this would be your shotgun surgery. You make a small change in one class, and that's going to change a whole bunch of others because you use the copy paste form of programming. Okay, this worked here, so I'm just copy it. I'm going to paste it down here and make a little tweak to the section that I need, and copy that and paste it down here, make a little tweak. Oh wait, there's a bug here. We need to rework that. Oh, I'm going to have to rework this. Got to rework this. Yeah,
Each clone has its own problems.
right, right. And then parallel inheritance hierarchies. When you subclass one class, you're going to have to subclass others. So it's a similar thing. This is indicative of using the copy paste approach to writing your code rather than saying, okay, if I've duplicated this code twice, if I've duplicated it more than twice, then I need to create a class and
Yes,
subclasses.
yes.
So but we'll get into the refactoring for each of these next week. Right now, we're just seeing what ugly code looks like. Dispensables. Yeah. This stuff just, you can just, these just don't belong in the code. Most of the time, comments aren't needed. Especially, I'll show you my favorite kind of comment to get rid of. Where is this main activity? Right there. Commented out code that is still left in there. We have source
Exactly.
code control. If you need to
Yes.
go back and find some code that was deleted, look at your history. You can find it. It's gone.
I
It's
just
there forever. There's no need to
yes.
keep this cluttering up the code, which, you got to find your way around. If you got something like this, update height, why isn't this a method called update height?
Yes.
You know,
Then you assign a name to this stuff. It's great. I just found a commented huge commented method in production. Then I told my friends we're not the maintainers of the project. We are just adding stuff to the project because we need it. And I saw some. I mean, you saw that we have a huge. They say pretend like that you didn't see it. Let's not talk about it because I don't know who commented. We have in production a huge block of code commented, and as you said, we have version control. Why do this? Test. It's not needed. Go away.
right? Amen. Preach, brother. Then you
Awesome.
have duplicate code. I mean, you've seen that. We clearly have some of that here. You go to, let's see here, you got your settings, settings data, and settings history. This is
Oh,
almost the same code.
exactly.
So that's going to, copy paste. Then you've got a data class. It depends on the kind of thing you're writing. Java went and created a record object, which is designed for your to handle it where you need a data class. But like in here, you've got this data share. This is just public variables.
It doesn't even have a long block. Doesn't even have a set getters. It's maybe just parse the object from a request and it exists.
Right, right. I mean, this is
How do they assign it?
just makes you feel. Oh, because they're public.
Ah, public static. Oh,
Yeah.
sorry. I was looking, thinking about private. No. Oh my
But if
God.
yeah, so
JavaScript.
yeah, this is only used in two places. This is only used in two places. This is
Oh,
commented out. Don't get me started.
awesome. No, this project it serves a mission
Yeah,
to show everyone not how not to do it. Oh.
yeah. And then there's you've got this, at least it's got a constructor, but and
And uh, and
and
it's private. At least it's private.
right.
Oh, then comes the public.
So basically, this could be turned into a record, but I mean, you've got this is never used. This is never used. This is never used. This is never used.
It's a
Why do you
beginner
have it?
class. It's a
And
beginner
it's
class. You create fields and set getters and setters to everybody, even if you not use. If it shouldn't be changed, then you get setter. Oh man.
if you're going to just have a getter setter like this that doesn't do anything, then yeah, this is fine. Just make it public. That's all you're
Yes.
doing is just putting get in front of it.
Yes.
That's kind of silly. But this, it's like this is a write-only value. You can't read it. There's no way to see the order ID. Why write it there?
Yes.
All
Oh.
these. No one ever uses these. Well, why even save it? Okay. Next we have our dead code, which is here's some dead code. It's just never used. A lazy class. This is a class that um, it's only used once or twice, and it doesn't do a lot. It's like just inline the darn thing. Um, you don't have to break out everything. Um, and then speculative generality. That's when you have getters and setters that you're not going to use. Um, again, you ain't going to need it. Why put it there? Take it out. Okay, and then couplers. Um, basically, if something is tightly coupled, then it makes it really hard to make any changes to it.
You know what?
So,
When one starts, then another ends. It's all mess up.
right. So you got feature envy. Um, that's where method accesses data from another object more than from its own class,
Oh,
which is like, yeah, I'm always looking at somebody else's stuff. Inappropriate intimacy is well named. I keep
awesome, man.
using, I'm calling data and methods from another class. It's like, well, maybe this function needs to be in that class instead. An incomplete library class. So I'm using a library or a utility class, but it doesn't do everything that I need. So I kind of I have to wrap everything that I'm calling from there. Well, maybe we ought to add stuff to that library or
Yes.
add
An
stuff to that
incomplete library.
utility. Right.
Yes.
Of course, if it's a third party library, then maybe I ought to use a library that's more complete. Um, message chains. You see something, A.B.C.D, and where you're calling deep into an object, it's going to make it really hard to make any changes to those objects. You have to know how it's structured. And Uncle Bob calls this a train wreck, because it's just digging down into
Awesome.
it. This is not the same as like a builder pattern or a what's it called, a stream. Streams, you'll see lots of dots and lots of,
Yes, yes, yes.
but
No, you are going into an object, then you go into a property, then you go into another thing, then you start to go into the 50 level of the object.
right, right. And it's, like I said, it just makes it hard to maintain that or make any changes to it.
Yes, yes.
um then you got your middleman. It's basically just a wrapper around some other data. So it yeah, it only exists to, what is it? There's the guy in Office Space where, what's your job? Oh, I take the specifications from this department and I deliver it to the development department. Okay. Do you do anything else? No, that's about it.
Uh,
Okay.
And that's rappers. They are another problem. Somebody decide to rap something, and then you have to wrap all the classes, and then you start receiving the same object but wrap it around something because one class needed a method and wrap it everything around
Yeah.
it.
Yeah. No, well, now sometimes it's good to have a wrapper, like if you're using a
Yes.
third party library
Yes.
and
To decouple the thing, but
you want to decouple it. But if you're doing this internally, you probably need to look at that. That's probably not the best way to do things.
in the class,
So,
as you said, just grab something and give something, grab something, give something. Why use a
right.
wrapper?
So these are all examples of bad code. And as grandma says, if it stinks, change it. Right.
Things you can tell to about kids and programming.
That that applies to code as well.
Yes. Uh,
So so yeah, that's basically what I have to show for you today. I guess it's a
awesome.
little shorter class than usual. Here's our homework. Just find an open source project, um, and find an example of at least five of these code smells. Um, Probably not hard. You probably find it in your code at work.
Yes, I was going to say that. Oh, no, no,
Explaining those two.
doesn't. I won't have to search a lot. Yes,
You know,
we have lots of these problems because, and we think that maybe sometimes they were hiding people not really well trained, and people were not the owners or maintainers of the project. So they were they were putting code and going away. So we have lots of these if else's, huge if else's, classes of 4,000 lines and everything. So it's not going to be hard to find an example.
okay, good. Yeah, and basically you told me about examples that you could think of as we are going through here.
Yes,
Also,
yes,
if you think about it, the code that that we write, we generally I'll go ahead and stop sharing. We write code because we're doing our best. We're doing the
yes.
best with what we have, and so it's good fun to make fun of bad code. But frankly, I can look at code that I wrote last week and make fun of that. Um,
Yes. No, in the beginning of a sprint, we have our meetings and say, no, I was just starting. I'm writing really bad code because I want to see the stuff working. If the other way around, it's over engineering. Then you
right.
start, no, I'm going to use all the patterns and good practices. And you have a single method implemented in a 5-way class with 2 patterns. No, it's not that way. But you
Yeah,
have to find the place in the middle.
absolutely. Yeah, and that's what we were talking about last week, the week before TDD, when you've got a you've got a broken test, you make the test pass, then you go in and refactor it to make it all look good. You go in and start figuring, okay, there's a better way to design all of this and have it hang together.
Yes. I,
But
I always started writing pretty bad code, silly code in a
mhm,
manner. So you have to know the smells because oh, I put lots of smell here. I have a huge if else. I have this class that doesn't do nothing. Then you
right,
start refactoring. But first I have to start making the code work. No?
right. And also, if you're wanting to write your code, your Java code in a functional way,
Mm.
and you're not really familiar with functional way of thinking, go ahead and write it in your regular,
It's
uh,
unreadable. It's it's a
and then go back
nightmare.
and rework it. Say, okay, here's a loop. Okay, great. I know how to handle a loop. Okay, I can create a stream here. All right. Oh, and I'm checking to see if it equals. I bet I can do a filter. Okay, and so yeah, you can just start to build it up that way, one step at a time. But getting it working is most important because if you ultimately can't get the functional approach to work, you got something that works.
And try to sort a functional work code that doesn't work. It's harder than trying to sort a normal code that doesn't work, because when you have functional, you have lots of code that you don't know what's doing, or it's hidden behind some 2 points. It's
Right.
a problem.
Yeah, yeah. But I mean, yeah, a lot of times you don't, yeah. I know I'm guilty of this. I don't really know the functional method as well as I should. I
Yeah,
use
no,
it. Oh,
exactly,
it
exactly. That's
surprised
the
me.
problem. Try to sort something written in plain Java. It's really easy because you have the variables and you assign it, then they are ready. When you put in the functional, great, you have shorter code, but you have a readable code, because what is happening here? You have a method, then you have to try to find out what's going on. Then you have the deeper another method. Oh, I don't like the functional. That's the problem. I
Right,
prefer to write it and then improve it. Put function when you have to write shorter codes. Yes, yes, that's another. It's like a modern smell. You have the functional smell.
right, right. Yeah, well, and we should be getting better every day, right?
Yes, yes. No, I write really bad code lots of time. Then you go to code review. I like to do it a lot because most of the times we're not really familiar with the code you are working with. Lots of situation you are, but then someone asks you to help. Okay, you go to a project, you see what's happening there, but you're not really familiar. So I write a really simple code just to see if I'm meeting the requirements. Okay, I have to do this. It's working. Okay, now let's improve this code. Then you start. I like these sessions to be a pair coding or a code review, because the other one who's reading maybe have some another experience with that code or that project. It's really how I like to do. Write bad code, then improve it.
Right. There you go.
Awesome, Scott. Awesome. Great example. It's really fun.
And let me see if I can bring it up here.
I was really interested in mobile, but then when I started work, I had to go to where it pays and have lots of uh, opportunities. So I began looking at mobile, learned some
Mhm.
Kotlin just for backend, because I saw that mobile didn't have lots of classes here.
This grammar slide rewrite. See, and there's slide RSS. Maybe he took it down. See here, slide rewrite. Rewrite a slide for Reddit. So
Mm,
yeah, I guess he took that down. There's no
no,
forks, and it's not forks from anything.
he didn't know that his project was doing was serving a purpose.
Yeah, that's the way it goes. And it's just
Uh, oh, too bad. Lucky that you have it there to use X example.
I'm glad I brought
You
it,
forwarded it. Yes,
made it
yes.
local first. So
Commit it in a private repository in our GitHub to keep it.
let me see if I've got it in mine here. Um, so my repositories slide right there. Boom. And if I go to add free Reddit browser for
Slide is that.
slide is dead. Yeah. Um, okay. So yeah, I know I forked it. Oh, I don't want to do that.
No, 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 no.
I
No, no,
won't recommend
don't bother. Don't bother.
it to the original, but yeah, yeah. If you want
It
to go
it's
look
a
online,
rabbit hole. If I'm starting to figure with it, I'll
here it
lose
is.
some hours.
Haptic apps
Haptic apps.
slide. Project will be on indefinite hiatus for the foreseeable future, may not be maintained. Updates are not guaranteed. Oh, it's good that the original author figured out that okay, I haven't. You can see that if you look at the releases that they were fewer and further between. That 20 nothing happened since 2021. Yeah, I guess he's done.
Yeah, as you said, you have to put some code, write it, and I think he might have received lots of contributions. I don't know if
Mhm.
he was coding it alone. I really doubt it.
Yeah,
Maintain a open source project. It's a Linus had to come up with GitHub because he was really pissed about the contribution. So it's not really a easy task. No
okay. Well, I won't keep you any longer. Um,
problem, no problem. Let's start with the to-do list.
yeah,
Thanks, God. That was great, great, great. It's really good to talk because we have to review what we are doing.
yeah,
And me, I'm the beginner, so I'm the beginner. I mean, the code. I always feel this. No, I'm too bad. I doesn't know what this code does, and sometimes this code smell. And then I put some code smells in the code.
right, right.
That's awesome.
Okay. Well, you have a great day, and we'll
Great,
look forward to
Scott.
seeing you next week.
Have a great weekend. Bye bye.
All right. Thanks. Bye.